And this one is just an idea sketch coming from MIT about floating. Now it is about wind power system. Wind power is getting bigger. They, when is it? 1980, 40 years ago, it was about 50 kilowatts, and diameter is 50 meter. 50 meter can be 3 floors height of building, right? 50 meter, 3 or 4 floors height of building is rotating. But now it's growing into 10 years ago already. 10 years ago, it is 10 gigawatts of electricity is coming, and the diameter is 180 meter. 180 meter. So it can be a big ship in terms of length. Right? And in terms of building, we can expect how many floors of this building, of the site. Let me say divide by 5, then it can be 36 floors. Right? Very big building is rotating. And rotating, how fast is it? Once a week, once a second, or once a minute? Several tons per minute. Right? Several tons. It's very fast. Because that speed means if you calculate the speed at the tip, it can be faster than sound. Can you remember the speed of sound? 360 something, 330 meter per second. Right? See, the tip speed is faster than sound because it's big and rotation speed. And also, this is a home heaters, right? You can use this one in your home sometimes, right? Probably in Korea you should know. And the kilowatt is only two, right? 2 kilowatts. So you can see the output coming from the power system. And also, the nuclear power plants. The output of nuclear power plants. Output, nuclear power plants. Size, number. 100 megawatt. 100 mega. More. Gigawatts or produce nuclear power plants. So that you mean that we need 100 of them to replace one nuclear power. Another problem is wind speed. Wind is not blowing anytime, right? For nuclear power is you can do continuously, no stopping, There is a big difference. Wind is blowing, but stopped and then blowing, right? So there is a fluctuation. So it's not continuous, but electricity should be continuous. There is items we need to understand about this. The trend of wind energy system. So it was started as land fixed type and small size. Enocom was 6 megawatt in Germany. That was the probably biggest one in land based. And then it moves on to shallow water, but bottom fixed, similar to offshore plants. And nowadays they are moving more deeper and far away from the land, so it is something like a floating wind and more bigger. So the merit advantage and disadvantage is simpler and safer, probably, especially for the operation and maintenance. This is good. But problem is noise. I have one experience that not this building. I'm in another building, my office. We call this is a Eureka building. Name of building is Eureka because the ocean engineering department was there. It was 7th floor building. This one is 6th floor. We had a research R&D project about wind power system at the time, 10 years ago. So that one professor buy a small wind power system for research purpose, not production of selling electricity. So it's small like say 2 meter, 3 meter diameter of blade, and then we install that wind power system on top of the building because the wind is good there. 7th floor, top of the building, and the space is good. But we take out after months because of the noise. It is very low frequency speed noise, low frequency. And then especially in the night time, many people in the building complain about the noise, so that we pay more money to take out the far away side. So noise was a problem, and also you can imagine that the size is bigger and bigger, the noise level can be higher, right? And also the installation area, land area should be larger, right? Then it costs higher because of the land cost. And the ocean bottom fixed is in the middle, and the floating can be more bigger and more land cost. The problem is the cost of itself, because it's a floating type, or maintenance is not good because it's far away, as a big, right? Height is 200 meters. If it is collapsed or break, how can you repair them? It's not easy, right? And also electricity coming from that side to the land is also cost. So there is an advantage and disadvantage. You see more later stage. This is I guess sketch of mobile harbor, floating port, and there was a project about mobile harbor in KAIST. So this is an output of the KAIST research about 15 years ago. And TEU is a unit for counting containers. You know what is TEU means? Have you seen the container boxes transporting in the roadside by truck? No? You never see the container is moving in the street? Road, car? No chance? So then how do you know the container is moving covered? Oh, train also carries. Yeah. But finally, you need to carry by truck, one by one. One container, one truck, moving to the final destination. For me, as I told you before, that I was moving from United States to Korea by including my car there. I told you about this. But my total amount of moving was 2/3 of containers, not full container. So that for the company, collecting company, they put another cargo to pack full of container box. Anyway, that container box should be delivered to Korea. Then I somehow get my household and cars. So, delivered. So TU is a 1 unit for container box. 1 box. 20 foot equivalent unit. Okay. Then it is another type, right? Another type. Why with T 20? It can be 10, it can be 30. So another popular size is a 40. 40. Is a 20, 40. So it's doubling the size. Doubling. Otherwise, if there is a mixture of 10, 30, 50, you cannot packing up clearly, right? So it's popular that 20 or 40. Then you can mix both the loading and unloading, right? And this ship or proposed ship can handle up to 250 boxes of floating. And this is a picture coming from the port of handling containers. For me, it looks like a 40-foot container. And then, oh, here is a video. See this.
혈압이 올라가는 주요 원인을 아세요? 콜레스테롤이 내막에 쌓이기 때문이죠. 콜레스테롤을 제거하려면 쌓인 콜레스테롤을 제거하는 좋은 콜레스테롤 HDL을 올려야 합니다. 레이델 폴리코사놀 더블 액션.
Let me show you how containers work. It's possible that most things around you right now came from a container ship. The food you ate, the phone or computer you're looking at. We have anything from apples to frozen meat to explosive or toxic gases on the ship. Some of the things we carry is pretty bizarre. But everything actually begins in the office with a team of people we call central planners. They drop cargo plan for the whole supply chain. Then it's sent to a chief mate to adjust as required. The containers are loaded by port's crane. Some say they were used by the Empire. Starting from the bottom, stacking up like Legos. These cargo holds can be as deep as 40 times 40 meters. The spades are built with these long sail guides that run downwards. It secures the containers in place. And this is what an empty container hold looks like. Once it's filled, a hatch cover is placed on top so that more containers can be loaded. The ones above on deck will need extra lashings to secure them. Workers from the port handle the physical labor of lashing. Thank God, because these full metal rods are very, very heavy. Turnbuckles are twisted to tighten the steel rods. For that, we have turnbuckles, short bars, long bars, and twist locks. There's actually a few types of twist locks on our ship. Some are manual, some are automatic. It all depends on the location of the containers, but they serve the same purpose, which is to lock containers. Once again, it really is just like stacking Legos. The fruits and frozen products are transported by reefers. Reefers are short for refrigerated containers. They are pretty much a gigantic portable fridge. It can keep temperatures anywhere from room temperature to negative 30 degrees. That's negative 90 Fahrenheit for America folks. So what's my part in all this? Well, as third mate, my job during cargo operation is to monitor the loading and discharging progress. Afterwards, checking the lashing to make sure it's done properly. The last thing we want are containers falling into sea if we ever run into bad weather. Other than that, we keep watch on the overall condition of the ship, including safety and security, checking the mooring lines and looking out for any suspicious activities like stowaways or pirates. So that was a general overview of how cargo operations are done on container ships. If you got any specific
Right. Question. No. Aircraft carrier. For the Navy. So it is a airport or air base. It's floating air base, right? Floating air base, right? It's a American Nimitz class, length, and displacement of ton, and speed, and power plant is nuclear. See, 260 horsepower. If you convert in this into diesel engine, you need over 80,000 horsepower. So it should be nuclear. And then carries 90 aircraft. Our range, I already helped you that conversion between horsepower and watts. And this one is 2 kilowatt at home. And large wind power grows into 10 megawatts nowadays. I should correct this one. And then the commercial nuclear power plant is bigger. Underwater habitat, the apartment, house, underwater, house. But you can stay there because place like Singapore, Tokyo, they are nearby to ocean, but very high cost of houses there. Right? Land cost and house cost is high. So that there is a commercial construction company or shipbuilding company, they want to build house underwater. Can be economical, right? Depending on. So they have a plan. I don't know whether I heard that there is a experimental housing already, small size, not big size. Good thing is the temperature range is very not fluctuating. Cool down. Right. Cool on the light and also diving equipment. Maybe we have tried diving yourself. No chance. Nobody tried diving yourself. Scuba. Scuba is a short name for self-contained underwater breathing apparatus, and was developed no time, 500 years ago. Gustav Kapner Apollo was invented. It's a compressed air, compressed air cylinder, and regulator is trying to lower down the pressure. The key element is compressed air cylinder and regulator. And then diving bell. Diving bell. For Korean, diving bell is very famous because of the several case. But in old days, there is a classical long time ago, only beer bell.
Is it famous because of what? What is it? Why is it famous in Korea?
There was a disaster, very good, 80 years ago. And more than 300 people died because of just ship. Very. And then after that, there are many tries to save them or find out. So people are one of people saying that we need to use diving equipment. The government did not use that diving equipment. So there was a big debate. That's why many times the TV, radio saying diving gear. Diving gear is not popular to you, right?
I've seen it.
Hmm?
I've seen it in the videos.
Oh, you see. Also, there was a film of it. Right? Anyway, so it looks like it's very similar to the bell, right? Bell. And there is no device, only bell. But they capturing air inside so that people can stay there, breathing. Because without bell, you need to go up and breathing and go down, but it takes time. So that it's good to have a air bubble there and go inside and breathing and go to work and then come again. It's a more convenient. That's why the old type of diving building. But now it is more advanced. It means it has a compressed air chamber, right? Same as a space shuttle. You need to have a 1 atmosphere compression in the space. Same as, but there is no vacuum there outside. But underwater, high pressure. So you need lower down the pressure. So the inside the bell, they provide 1 atm, same pressure like this, so that people can stay. So this is something small submarine. Also very similar to space shuttle, space suit, but the pressure direction is reversal. Also, they can use this kind of items. Classification of ocean, vehicles or ships. Surface vessel. This is very popular one. Surface vessel. And then what kind of manned surface ship? And also nowadays, unmanned surface ship is more popular. Small size. Underwater vehicle, submarines, submersibles, but there is also increasing number of unmanned underwater vehicles. And others, this is very special one. We call this a WIG. Wing in ground effect ship. Wing in ground effect ship. So it looks like an airplane, but they fly very close to surface, several meters only. Then it is good for lifting because of the ground effect or aerodynamics. Then economy for lifting heavy cargoes, cheaper. Then normal. Submarine and submersible. Submarine is for Navy usually. Right? The submersible is small one, but more deeper size for the scientific investigation. Something like 6,000, 10,000 meters, 10 kilometers deeper. We need to have a special small size video camera and sensors and also artificial hand. Robotics, two kinds. One is ROV, the other one is AUV. Right? ROV is a remotely operated vehicle, short name. And AV is autonomous underwater vehicle. The difference is there is a cable to the ship. ROV, cable. This one, no cable. Then this one need to have a battery operated. Battery. There is no battery. So power cable, and so the cable has the function of providing electricity and also communication. Communication means the control and sensing. Because underwater, it is not easy to have a communication. So the division is very clear there. We call it umbilical cable connected. Now we are moving toward the unmanned ship. So there is a very much R&D goes on nowadays to build first of the unmanned ship. The appearance is different because there is no hotel on top of the ship. Usually the ship has a hotel like this one, so that at the top floor captain is located, pilot house. Right? The unmanned ship, there is no such one, so it can be looks like a submarine. And we need to have some kind of observation camera somewhere and communication. So this looks like also submarine port. And this one is also idea sketch of container ship, or unmanned container ship. So idea sketch was coming from Norway. I heard there is a one small one is operating near Norway Sea. Fjord, something like this one, small unmanned. Testing, they are already built small one and testing. Right? And this is communication. 미끄러졌네. 여기 자생계란. 여기가 안 되면은 다른 학생들도 다 보고 있을 거다. So this one shows you under the drone. Small under the drone. Or A, B. Understood that does not have any problem. Right, this is another type of the drone. Looks like I guess all right. No question. We can have a 5-minute break.